Hi everyone. Today we are looking at the topic water, and in this topic we will look at the different states of water. So you would learn in this topic that water can exist as three different states, in a solid state and a liquid state and a gas state. And in this topic we will look at how each different state allows water to do different things. So first up, let's look at the different states of water. So water exists on Earth in each of the three different states. It can exist as a solid, such as ice or snow or glaciers, for example. It can exist as a liquid, such as liquid rainwater, and also clouds are made up of liquid droplets, as well as gas. So in the atmosphere, you would find water vapor, and that is water in its gaseous form. And 1% of the water in the atmosphere is water vapor. So we can see that water can exist in all the three different states on Earth, as a solid, as a liquid, as well as gas. So this ability of water to exist in these states has influenced on the evolution of the Earth in geological and biological terms. And what does that mean? That over time the Earth has changed. So from initially there was no life on Earth. But over time, the living things started to live on Earth, and as a result of that, the Earth has changed over time. And water has had a very strong influence on this change in Earth. So water had a very strong influence on the evolution of Earth. Now let's look at a water cycle. So what happens in the water cycle is that water in the form of liquid is first comes out as rainfall. So what happens is rainfall occurs and it fills your groundwater and your lakes and river. But then when the sun is hitting this water, some of the water is evaporating due to the heat. And this is water in the gas phase. So water vapor is evaporating and going back to the atmosphere at the top. And then the process of transpiration occurs, where the water vapor converts back to liquid water droplets. And due to the process of transpiration, again, the clouds form. So the water vapor converts to water droplets and forms the cloud. So over time the water droplets start to collect in the cloud, and at one point the cloud cannot take the water vapor anymore, so it has too much water droplets in it already, and that's when the rain falls. So again the whole thing starts. So the rain falls, it fills your oceans and lakes, and then due to the heat from the sun, the water evaporates, goes back up to the atmosphere, where it is converted to liquid water droplets that forms our clouds that join together to form our clouds. At one point there is so much liquid droplets that the clouds can handle them anymore, and that's when our rain falls. Now let's look at the role of water in cells. So living units, that is cells, can reproduce themselves when isolated from any other living units. So we know that cells can reproduce by themselves by a process called binary fission. So one cell divides into two, those two cells divide into four, those four cells divide into 8, and so on. They are surrounded by a semi-permeable membrane. Now what does semi-permeable mean? Semi-permeable means that they only allow some substances to get through. So all substances cannot get through the cell wall into the cells. Only some substances can get through, while other has to stay out of the cells. And same with substances going out of the cell. We don't want all the contents to go out of the cell. We only want the wastes to go out of the cell. That's why we have a semi-permeable membrane which controls what goes in and out of the cell. Now the sum of the total chemical reaction taking place in the cell is called metabolism of the cell. Water is the most common compound in organisms. Cells contain about 70% of water. So as you can see, cell has most of the cell is water, so only 30% of the cell is other things such as the nucleus and the vacuole and the cytoplasm, but everything else is water. And you will also know that the cytoplasm of the cell is a liquid medium, which is mainly water. And water acts as a solvent, where different substances are dissolved in the cell and the chemical reactions occur as water. So water acts as a medium for chemical reactions to take place in our cells. Now let's look at some properties of water relating to cell. So water has a fairly high surface tension. And what is surface tension? Surface tension are forcing acting on the surface of water, and this allows the cell to maintain their shape, because if water did not have a high surface tension, the cells would not be able to maintain their circular or rectangular shape. They will be really they can be easily moved, and their shapes can be easily broken, so they would not be contained in a particular surrounding semi-permeable membrane. Also, the surface tension of water allows insects to walk on water, because again these are the forces acting on the surface of the water, so it forms a imaginary plane on the surface of water which allows substances to flow, or also allows cells to maintain their shape. Water also has a high heat capacity and high vaporization, minimizing sudden temperature changes. Now, what does high heat capacity means? That means you need a lot of energy, a lot of heat energy to significantly change the temperature of water. Also, you need a lot of heat energy to cause the water to evaporate from solid to a gas state. So that's why water has a high heat capacity and high heat of vaporization. We will look into these terms in much more detail in the following slides. And also, this minimizes sudden temperature changes, because you need a lot of heat to change its temperature significantly. That means the temperature change is not sudden. Temperature change in water occurs at a very, very slow rate because of these two main properties. High boiling point compared with naturally occurring surface temperatures on land. So you know that the surface temperature on land is about 25 degrees Celsius, but water has a boiling point of 100 degrees Celsius. So you can see that water has a very, very high temperature compared to the temperature that occurs on natural land. And also that has a benefit, because if water had a lower boiling temperature than the temperature that occurs naturally, then all of the water in our oceans and lakes would evaporate, and we will not have any aquatic life. So that is something that we don't want. So again, because water has a high boiling point, not all of the water evaporates, and therefore we have an aquatic ecosystem in our planet Earth. Now let's look at again how cells and water relate to each other. So for cell metabolism to occur, the reacting substances must be dispersed. And what does that mean? Because of the reactions that occurs in the cell, we want different substances to go in and out of the cells. Now, again, those substances do not have legs that they can just walk in. So they need a transport medium, and water acts as their transport medium. So water is the transport medium that dissolve substances in the cell, such as oxygen or carbon dioxide, and they take it to different parts of the body and provide it to the cells in those parts to carry out their metabolic reactions. So since water is a polar molecule, it can form hydrogen bonds. So it forms hydrogen bonds to the substances so that they stay dissolved in water while they are distributed around the body. Again, it can cluster around organic molecules and ions, which are then said to be hydrated or dissolved. Because it can cluster around the organic molecules or ions, it can carry the individual particles to the different cells, and then the cells can use them to carry out their metabolic reactions. Now, hydration is a very important factor, because hydration allows the cells to store water in their protoplasm. So the cytoplasm is also known as the protoplasm, and it's a liquid content of the cells. So as you can see in the picture, the most of the cell is the cytoplasm, which is the liquid content, and therefore hydration allows the cell to contain more water, because if the process of hydration did not occur, the cell would dehydrate and die, and all of the water from the cell will come out, and we don't want that, because then our body cannot function properly. So we need to make sure that the cells are dissolved in a liquid medium for the reactions, the important metabolic reactions necessary for life to take place. Now, water also plays an important role in other processes, such as in green plants. It has a major role as photosynthesis, because you can see that it's one of the major reactants. So in photosynthesis, you can see carbon dioxide and water as well as light energy goes to the leaf, and then this process takes place that produces glucose, which is the food for the plants, and it also produces oxygen, which living things such as us as well as animals need to breathe. So again, the process of photosynthesis is very important because the products formed are necessary for life on Earth. And again, water is one of the major reactants in the process of photosynthesis. So we can see that water is a very, very important substance. Also, water is necessary for digestion. Again, digestion occurs in us as well as other living things. So let's see how digestion works. So starch, the food formed by plants, plus water, and there is some enzymes involved in it. So what are enzymes? Enzymes are substances that speed up a biological reaction. So enzymes are actually biological catalysts. So they lower the activation energy and they speed up the reaction. So in our mouth, when we are having sugar, for example, so if you take a spoon of sugar, you have water in your mouth, so the starch and water react together, and there are salivary enzymes in your mouth such as amylase, which breaks down the sugar molecules, and it forms maltose, which is digested form of sugar. So now when our body can easily digest the maltose, not the starch in its complete form. So what happens is the water allows the starch to break down into maltose, which can be easily used by our body. Now let's look at the significance of water in the cellular environment. So about 70% of the cells are water because most of the cells, as we saw in the diagram, are cytoplasm. So most of the cell is water. It's an important solvent because we have already looked at the fact that most of the metabolic reactions occur in water, and also water is a transport medium that dissolves substances in it and transports it to the different cells, and then the cells can use those substances to carry out the reaction. So it is a very important solvent in our body. Also, it's an excellent medium for chemical and biochemical reactions to take place. Again, all the metabolic reactions in cell occur in the cytoplasm, which is the liquid medium of the cell consisting of 70% water. Also, it acts as a transport medium. So we have already looked at this property of water because water carries various minerals, nutrients, respiratory gases such as oxygen and carbon dioxide and waste in multicellular organisms. So what water does, it carries these minerals such as vitamins and proteins and other nutrients, also respiratory gases such as oxygen and carbon dioxide, and it transports these gases to different parts of the body, and then the parts of the body use those gases or excrete the gases according to their needs. And again, we can see the water is very important in our cellular environment because it plays three major roles, as you can see from this slide. Now, water is also a reactant for photosynthesis in green plants, and we have seen that carbon dioxide and water reacts together to form sugar and oxygen. Again, two very important products that are necessary for life on Earth. Water also provides support for tissues because we know that water has a very high surface tension, which allows tissues to keep their own shape, also so that the tissues are strong and does not easily rip. That's why water is very important due to its high surface tension, which provides a support for our tissues. The cellular respiration of food produces metabolic water, which is an important source of water for living organisms. And we have already seen the important role of water in living organisms because you know that it acts as a solvent, as a transport medium, as one of the reactants in the main processes that occur in our body, the metabolic reactions. So therefore, water is very important in our living organisms. Now let's look at the distribution of water in our body. So as you can see, different parts of our body has different content of water. For example, the bone contains 24% of water. The skin contains 71% of water. Fat tissue contains 30% of water. Muscle again contains 70% of water, similar to skin. And brain contains the highest amount of water, which is 80 to 85%. Now this slide definitely highlights the importance of water in our body, because as you can notice that all the different parts of our body has some content of water, especially the brain. And you would know that brain is one of the most important parts, because it allows us what we do. Also, it allows different parts of our body, so the different organs of our body, to function properly. Because what the brain does, it instructs our body what to do, both are internally and externally. And you can see that most of the brain is water, and therefore, again, highlighting the point that water is a very important substance. Now let's look at the properties of water in a marine environment. So ecosystems that occur in our oceans and seas, water also has a very important role in those ecosystems. So let's look at what? So the thermal properties of water, again, thermal means heat. So we will look at the properties of water related to heat. So water has a high heat capacity, and again, that means that we need a lot of heat energy to increase the temperature of the water or change the temperature of the water significantly. Also, water has a high heat of vaporization. That again means we need to put in a lot of water to cause it to evaporate. And that is very important, because if water had a low heat of vaporization, all of water will evaporate and we will not have oceans and seas. And we will not have an aquatic ecosystem, and that is something that we don't want. So the high heat of vaporization and the high heat of capacity has very important role in our natural ecosystem and again life on the planet. So these properties helps to stabilize the temperature of a marine habitat. Again, we as humans don't want our temperatures to fluctuate very rapidly. And same with marine environments which has living things in it, such as fishes, frogs, etc. They do not want the temperature to change rapidly. They want the temperature to be stable over a long period of time. Again, because the body is not suited to fluctuating temperature. That means if temperature does fluctuate rapidly, they will not be able to survive, because chemical reactions can only take place at a certain temperature. Also, the enzymes in our body can only work at a certain temperature. So we definitely want a very stable temperature for life to continue. And again, because of these two properties, which means that water changes its temperature very slowly, it allows us the temperatures to be very stable in our marine environment. So by day, the oceans do not reach the temperature of nearby land on a warm, dry day. And why is that the case? Because again, water has a very high heat capacity. That means that if we even give a lot of heat, the temperature changes very slowly, because water has a very, very high heat capacity. So at night, the temperature drop is less in water than on land. Again, due to the factor that water has a very high heat capacity, so the temperature change during the day or at night is very slow compared to land, which has a very low heat capacity compared to water, and therefore the temperature of the land changes much more quickly. So again, in a summer season, the land will heat up much more quickly than the water. So again, if you realize that when it's really hot, you go down to the beach just to cool yourself up. And why is that the case? Because the ocean water does not heat up very quickly. It still stays cool over the period of the day. Therefore, in a summer day, you would go down to the beach, for example, just to cool yourself up. And this again is due to the fact that water has a very, very high heat of capacity. So we need a lot of heat to change the temperature of the water dramatically. So in cold winter conditions, oceans will not normally freeze, but frost, snow and ice can occur on land and ponds. So we know that the land can be covered by ice, but again the ocean doesn't. And why is that the case? Because we know from our previous topics that ice has a very low density compared to water, and that means the ice floats on water and it insulates the water underneath it, and that's why it stops the whole water body to freeze up. And again, it has very important functions in our living systems. So lakes and rivers can have a surface coating of ice which can insulate the water underneath so that the whole water body does not freeze and aquatic life can still remain. Now let's look at what specific heat capacity of water mean. I've already told you that heat capacity means the amount of heat that is needed to change the temperature of the water. And so specific heat capacity of water is the heat needed to raise 1 gram of water by 1 degree Celsius. So the amount of heat that you need or you need to provide to change the temperature of 1 gram of water. So that's what specific heat capacity of water means. Now the specific heat capacity of water is 4.18 joules per coulomb per gram. So as you can see, the specific heat capacity of water is quite high. Again, emphasizing on the fact that you need to provide a lot of heat energy to significantly change the temperature of water, because again, what is the specific heat capacity? It is the amount of heat needed to only raise the temperature by 1 degree Celsius of 1 gram of water. Again, because if the water has a very high heat of specific heat capacity, we need a lot more heat to increase the temperature of water. Now, what is the significance of having this very high heat capacity of water? So oceans, seas and lakes help to reduce changes in Earth's temperature, because if water did not have a high heat of capacity, the oceans of the temperature, the temperature of the oceans, will change very dramatically. So the Earth's temperature will not be stable. Again, if it's not a stable temperature, living things cannot survive on Earth. To survive on Earth, we need a very, very stable temperature. And because of the heat capacity of water, we can maintain a stable temperature. So oceans, seas and lakes help to reduce changes in the Earth's temperature because of the large values for heat capacity, as well as high heat of fusion and vaporization. Again, emphasizing on the strong importance of these properties of water and how they help life on Earth to maintain. So temperature increases are kept to minimum because water absorbs a large amount of heat per degree of temperature rise. So again, to increase 1 gram of water to up by 1 degree Celsius, we need a lot of heat and a large amount of heat when it vaporizes. So we need a large amount of heat to vaporize water from liquid to gas state. Also, only to increase the temperature by 1 degree Celsius, we need to input a lot of energy. In cold climates, ice absorbs a large amount of heat when it melts. Again, why is that the case? Because ice is water in its solid form. Again, we know that water has a high heat capacity, so we need to provide a lot of heat energy so that the ice can melt. So this has very significant impacts in places like Antarctica, where everything is ice. So if water had a low heat of capacity, all of Antarctica and all of life in Antarctica could not survive because everything would melt, and we don't want that. And because water has a high heat of capacity, everything can still remain as ice, and life in Antarctica can still continue. Now this brings us to the end of the theory session. Now let's look at some of the questions to test your knowledge. So the first question asks us to outline the importance of water in living cells as a constituent of cells. Now you should notice that the verb is outline, which means you just need to describe and you just need to list the properties of water. You do not need to explain why they are the properties, so what are the chemistries involved behind those properties. You just need to list the properties one by one. So what is the important role of water in our living cells? So all chemical reactions that occur in the cell, so all the metabolic reactions necessary for life that occurs in the cell occurs in a solution. So liquid water acting as a solvent is essential for metabolism. And why is that the case? Because we know that water dissolves substances needed for metabolic processes and they transfer them to the cells, and then the cells can use them to carry out their reactions. Therefore, water is very important because it acts as a solvent and also as a transport medium to carry the different substances to the cell, and so the cells can carry out their chemical reactions. Now let's look at question 2. Question 2 tells us, which of the following is not a cellular role of water? Again, make sure you notice the word not, because our habit is to look at something that's correct, but in this question we want to find something that is wrong. So let's look at each of the options. So first it tells us that one of the roles in water in the cell is as a transport medium for minerals, nutrients, respiratory gases, and waste invertebrates. And now this is true. And why is that? Because we know that water has the ability to act as a solvent, because it can dissolve different substances such as minerals, nutrients, and respiratory gases, and then it can transport it to the different parts of the body, and the different parts of the body can use those different substances to carry out the chemical reactions. Therefore, A is correct. So A is not our answer, because we want a role of water we want to look at something that is not the role of water. So A is not our answer, because this is a role of water. Water does act as a transport medium in our cells. Now let's look at B. It's an essential reactant in photosynthesis. Again, if you look at the reaction of photosynthesis, there is carbon dioxide reacting with water to form sugar, glucose, and also oxygen. So water again is a very essential reactant. It is one of the main reactants in the process of photosynthesis. Therefore, B is not our answer as well, because we're looking for something that is not the role of water in cellular environments. So B is not our answer. Let's look at D. D says that water is produced by cellular respiration of food. That is true again, because we know that water is produced by metabolic reactions in our body. Again, that water is used for very other different purposes in our body. So D is not the answer, because water is a byproduct of many chemical reactions in the body. Now let's look at option C. So C is definitely our answer. It says that the role of water is physical weathering, and this is not true. And why is that the case? Because physical weathering cannot happen in a cellular environment, because we do not want the cells to weather or get damaged, and water actually helps the cell, it supports the cell and helps the cell to maintain its function and to maintain its shape. So water does not cause any type of physical weathering to our cell. Water does not damage our cells, and therefore C is the correct answer. Let's look at question 3. Question 3 tells us, what are the two main thermal properties of water? Again, make sure that you mention two different properties, because the question specifically tells you to mention two different things, and also it just tells you to list them, so you do not have to explain them, because it only asks you what are the two main properties. So if you can remember, the first property is high heat capacity. Again, what does that mean? It means that we need to provide a lot of heat energy to increase the temperature of water by 1 degree Celsius. Water also has a high heat of vaporization, and that means that we need to provide a lot of heat to vaporize the water. So these are the two main thermal properties of water. The first one is it has a high heat capacity, and the second one is that it has a high heat of vaporization. Now let's move on to question 4. Question 4 tells you to recall the definition of the term specific heat capacity. So what is specific heat capacity? So you just need to provide a definition for this. So specific heat capacity is the heat needed to raise the temperature of 1 kilogram of a substance by 1 Kelvin degree. So it is the amount of heat that you need to provide to increase the temperature of 1 gram of a substance by 1 Kelvin degree. So that's what specific heat capacity means, and it only tells you to recall it. That means you only have to provide the definition. You do not have to explain it, or you do not have to provide any chemistry knowledge or chemistry properties behind this. You just need to provide the definition. Now let's look at question 5. Question 5 tells you that the specific heat capacity of sand is 1.09 kilograms per Kelvin, and water is 4.2 joules per kilograms per Kelvin. Now explain why does sand become warm but the water remains cool during hot days on the beach. Now as you can see, water has a much higher heat capacity than sand. Where water has a heat capacity of 4.2, sand only has a heat capacity of 1.09. That means that if you provide the same amount of heat, sand will heat up much more quicker than water, because sand has a lower heat capacity. That means if we only provide a little bit of heat, sand will gradually heat up a lot more than water. So because water has a high heat capacity, it requires a lot more heat for it to increase its temperature. So they both receive the same amount of heat in a hot day, but this makes sand hotter than water because water has a high specific heat capacity. It takes more heat to raise the temperature of water as much as sand. So you need to provide more heat to the water to increase its temperature compared to sand. Sand only needs a little bit of heat to significantly increase its temperature. Now this brings us to the end of the question session. In this topic, we mainly looked at the thermal properties of water. So we mainly looked at the high heat of capacity of water and the high heat of vaporization. We also looked at the role of water in different environments such as in cells and in also marine habitats.